Okay, proportions. A proportion is an equation stating that two ratios, right, which is just a fraction, are equal. And there's three ways that we can tell if a set of fractions form a proportion. Okay, so method number one is we're going to check to see if they have the same simplest form. I'm going to try to zoom this in, make this a little bit closer. Okay, so 10 and 24 and 25 and 60. So let's see, what are 10 and 24 both divisible by? They're both divisible by 2. So that gives me 5 over 12. Okay, here, what are 25 and 60 both divisible by? Those are both divisible by 5, which gives me 5 over 12. So are those the exact same simplest form? Yes, so these two fractions would form a proportion. Okay, let's look at this next one. 12 over 18 and 50 over 75. What are 12 and 18 both divisible by? 6, so that would be 2 over 3. These are both divisible by 25, which would give me 2 over 3. So these two fractions also form a proportion, right? If I set them equal to each other, they mean the same thing. 10 and 12, what are they both divisible by? 2, so that gives me 5 over 6. Here, these are both divisible by 8. 40 divided by 8 is 5. 56 divided by 8 is 7. Do these fractions have the same simplest form? No. Therefore, they are not a proportion. Okay, 3 over 5. This one is already in simplest form. 39 and 65. What are they both divisible by? 13. 39 divided by 13 is 3. 65 divided by 13 is 5. So these would be a yes. Okay, sometimes the simplest form isn't the easiest way, right? You might not know off the top of your head the 13 divisibility rule, right? Or you might not be able to look at that and know that that's divisible by 13. So you can use the second method, which is finding a common multiplier. Okay, that's where you look at things and you're like, okay, well, I know that 3 times 5 is 15. So what if I multiplied the bottom by 5? 11 times 5 is 55. So this would be yes, because all I really did, it's like saying if I take this entire fraction, multiply everything by 5, I get the second one. So therefore, it's a proportion. Okay, or like here, 4 times 8 is 32. 5 times 8 is 40. So these would be yes because they have a common multiplier. Okay, on the next one, I know 7 times 4 is 28. Well, is 21 times 4 63? No, this is times 3. Is there a common multiplier? Did I multiply the top and the bottom by the same thing? No. So therefore, it's not a proportion. Okay, so like up here on this one with the 13, I could have looked at this and said, well, I know that 5 times 13 is 65. So what's 3 times 13? And you would have said, oh, it's 39. So I multiplied the top and the bottom both by 13. And then the last way is probably going to be your way of choice, just because it's pretty simple and easy. So let's look at this one. Okay, it's called the butterfly or cross products. So here I can say, well, what's 12 times 6? Well, that's 72. And then 9 times 9 is 81. Do these have the same cross products? No. So therefore, they are not a proportion. Okay, so like here, 9 times 30 is 270. And then 54 times 5 is also 270. So this would be yes. Okay, but for example, this one, if it was me personally, I would not use cross products on this because I don't want to have to multiply 54 times 5. So if it was me on this one, I would be looking at this 30 over 54 and saying, okay, well, what are these both divisible by? They're both divisible by 6, which gives me 5 over 9. Are those the same simplest form? Absolutely, right? Or I could even look about the common multiplier and say, well, what's 5 times 6 to make 30? Well, what's 9 times 6? It's 54, right? So you don't have to use one method every time. You can use whichever one you prefer. Okay, 6 times 8 is 48. And then 16 times 3, that's also 48. So those two fractions would form a proportion. Okay, and then this last one, 8 times 5 is 40. And 9 times 4 is 36. Those do not form a proportion, so the answer would be no. And you could probably look at this and know, well, if I simplified this, it's 1 over 2. Those are not the same simplest form.